and negative 13.69 is the actual t-value, and p less than 0.001. Now let me just redo this paired sample t-test that has been done in a previous video, although the video resolution wasn't great, so I'm going to do it again here. Compare means paired sample t-test, and I've got resilience 1 for variable 1 and resilience 2 for variable 2. I click on OK, and here are the results, and we can see that the means are reported in the first table, and then that correlation, and here's the t table where the guts of the results are. And we can see that the t-value is equal to negative 13.689, and the degrees of freedom are equal to 49. That's where I got those values to input into this section of the results. And p is less than 0.001 because SPSS reports it at 0.000. Technically, you're not supposed to say something like p equal 0.000. You have to say less than 0.01 because at some level of probability there is a chance of rejecting the null hypothesis erroneously in this case. And I'll also mention just briefly, in the video I didn't test the assumption of normality. I'll just show you quickly how you can test that assumption of the difference scores. Just go into Transform, Compute, Difference, Resilience 1 minus Resilience 2. And that's going to create a separate variable called difference. And then I looked at the skewness levels associated with that difference score. Get into frequencies, and then click on the statistics button and look at skew and kurtosis. So you look at the absolute values, don't divide anything by the standard error. And then I've got the skewness here, negative 0.129 for skew and positive 1.698 for kurtosis. So these values are less than 2 and 9 respectively. So I've satisfied that Poston rule. Really, it's a rule that I've generated across a number of studies, but Poston looked at it extensively and corroborated this contention that it's very robust to non-normally distributed data. So once I've rejected the null hypothesis, you should never just stop with the p-value. Always follow up with a couple of other sentences, and in this case here, I said, thus the post-training mean was statistically significantly higher than the pre-training mean. So this is suggesting that the training or the training program worked. I like to see an extra sentence after the statistic. What did you test and what does this mean? Don't go into discussion, just a very mechanical statement about what has been found here. The post-training mean was statistically significantly higher than the pre-training mean. That's what this t-value is telling me. Now I followed up with Cohen's d. I want an estimate of effect size. After you report a p-value, you always want to follow up with an effect size estimate. In this case, Cohen's d is estimated at negative 1.35. And there are some how-to stats videos on Cohen's d that you should check out if you don't understand Cohen's d. There's even a calculator on the how-to stats website that'll calculate it for you. And I estimate that the effect size is large based on Cohen's guidelines. Now finally, there's a graphical representation of the means. Now in different disciplines you'll see graphs reported more frequently than others. In cognition, for example, you'll see a lot more graphs of just basic two means. And in this case, with the repeated measures design, you need to use an adjustment to calculate the 95% confidence intervals, because ultimately it's because of this correlation actually between time 1 and time 2, which reduces the size of the standard error of the difference between two means. And so let's go look at that graph. Here are the references that you might want to check out or reference in your own work that I've used in the results section. And here's the bar chart that's been created to represent these, and here are the 95% confidence intervals, which are adjusted. These are adjusted for the fact that we're using a paired sample design or a repeated measures design. So here's what the figure looks like. You should try to make something similar to that. I should make a video at some point on how to make a decent graph. And here's the figure caption So figure 1 is italicized, and then you have a caption associated with that figure 1, which is not italicized. And I've just written resilience means and 95% confidence intervals associated with the pre and post training conditions. And that's what that looks like. So that's a walkthrough of a paired sample t-test. I'm going to make another video on how to create these. I'll make that video next, actually, how to create these adjusted 95% confidence intervals for a bar chart that is a repeated measures design. So I hope you enjoyed this video, and I'll catch you next time.